All right, what did bisect mean?
They're equal.
All right. It's going to cut something into two equal parts. So that means this part and this part are the same. So I say that ADB is equal to CDB.
So anytime it says bisect, we go ahead.
You're going to have something cut in half. Two things are going to be equal if you see bisector. It could be a side, it could be an angle. But you're going to have two equal parts. All right? What does that symbol mean right there? Perpendicular. What does perpendicular mean?
They're equal.
What?
Similar.
No.
They never intersect.
No.
Congruent.
It tells you something.
What?
Say it, right? Refund it, right?
Bisect means 90 degrees. Right angles. Bisect means 90 degrees. So, it tells me that BD is perpendicular to AC. So if they're perpendicular, that means right angles.
We write that down.
We're going to write it over here, and then we're going to say it in the proof. So angle DBA is equal to angle DBC. Why? What are they? They're right angles. Now you could say definition of perpendicular. That would be. We know they're both right angles, so that's what we're going to say. All right. What else are we missing that we really need?
A side.
What side? The one in the middle. What did I tell y'all about those?
Yeah, they are.
99% of the time, if you see that one in the middle, you're going to use it. So how do I write that though?
Try to
BD.
BD equals BD, and what is the rule? Why is the same thing equal to itself? Reflexive. If I ever have the same thing equal to itself, it's reflexive.
So now it's going to be angle side.
So then I'm going to say triangle, let's say ADB, would match triangle CDB because of what rule?
Bisect.
No, the triangles.
Sorry.
Angle, side, angle. But look at what it's asking me to prove now. It's asking me to prove that some sides are the same. So here's what's going to happen every time you have this, whether it's sides or angles. You get the triangles to be congruent first. All right? So get the triangles congruent
And
to
then you
start.
just say AB.
And then you can say, well, AB has to be equal to BC, and the rule is CPCTC. It stands for corresponding parts of congruent triangles are congruent. In regular words, if the triangles are the same, all the pieces are the same. The angles have to match, the sides have to match. So if you ever see a proved part where it's talking about some sides, the step before that is going to be talking about the triangles being congruent first, and then you'll talk about sides or angles being congruent at the end, and your rule is going to be that CPCTC. Corresponding parts of congruent triangles are congruent.
HK.
All right. It tells me bisect, so I'm going to mark those because it says it bisects that angle at the top. So HKI
Yeah, JKI.
and JKI. And that's because of the bisector. All right. It also tells me H is equal to J, so I'm going to mark that. What have we not said the same that we should be saying?
It's got right angle.
Nope. I don't know. I can't say it's got a right angle because they didn't tell me about perpendicular. What can I say the same is the same? The middle.
It'll be an angle side.
So Ki is equal to Ki, and what is my reason on that?
Reflexive.
All right. And we said what now? Triangle?
It's angle side.
Well, give me the, if I said, for example, HKI, what would match HKI?
JKI.
JKI. And that is angle, side, I think y'all said. Once I have the triangles being the same, then I can come to the proved part and say, well, HK has to be equal to KJ because of the CTC. All right, I'm gonna mark what they told me. AB and CB are equal. And then it tells me the perpendicular part. So what do I know about perpendicular? Right angles. So what are my right angles then?
ADB.
All right, ADB would work. CDB.
Or you could do ABD.
I could switch this and say BDA. I could switch that and say BDC, but the D has to be in the middle. So now I've got my right angles in there.
Yes, sir.
What else do I need to do?
You can get the middle of the.
I can do the middle.
So that means triangle.
Wait a minute. I need to say
Yeah.
BD equals BD because of
Flex.
reflexive. See, here's my thing. Even if you don't know the whole proof, you can get those two parts right there and get credit. And that's just what they told me right here, and noticing that I got the middle. And that's without getting it right. All right, now, why are the triangles the same?
Because of side angle side.
Disagree now.
Side angle
Is it?
side.
There is no angle side side, but there is something.
Side.
Side.
Mm-mm.
Angle side.
Angle side. Angle side. Oh.
Hypotenuse leg.
Oh. So.
I've got my hypotenuse here, and then I've got the leg there in the middle.
So you said if we
Well,
say
got it,
AB
got it,
equals
bro.
CB, we mark that.
Yes. Yeah, if it gives you AB equals CB, you got to mark that on the triangle.
And give you BD and AC.
That, well, it gives me perpendicular,
Okay.
so that tells me the right angle.
Okay. So
All right, I'm gonna mark the WX and the XY. And again, what does that tell me?
perpendicular.
Which means
BD.
right angles. So I'm gonna talk about some right angles. Where are my right angles?
WZ. I mean WZ.
WZX equals YZX because of the right angles, perpendicular lines. What else do I need to say the same?
X and
The
Z.
middle. XZ equals XZ. That's reflexive. Now what?
Do XZ of SDX. Triangle XD.
Triangle. All right, if I do X,
No, I mean WX, WZX
WZX,
equals
all right,
triangle
WZX equals
YZX, which is HL.
hypotenuse leg. So now I've got my triangles being the same, so I can say WZ equals ZY because of the CPTCC. All right, on this, it tells me parallel. That's a hint. What do I know about parallel lines?
You can have the consecutive on that.
Consecutive, alternate interior, alternate exterior, corresponding, all that junk. That's what we need to understand. They're telling me what to go with. What can I say is the same up here? What?
5-3 because of alternate interior.
And what else?
2-4-2.
So I know that, so I'm gonna say it. So I've marked these being the same, and I've marked those being the same. I'm trying to get to where I can say that 1 + 2 + 3 is 180. Can y'all tell me something up here that is 180?
4 and
4
5.
and
4, 1, and 5. Why?
Because it's straight to the
It
line.
makes a line.
So it'd be a little pair.
So I'm gonna say 4 + 1 + 5 equals 180. And what it's called is straight angle. It's not a linear pair because it's got 3 instead of 2. But so be it. It's a straight angle. If you have a straight angle, it makes a line, line's gotta be 180. Well, now what? I've got something being 180, it's just not the right thing.
And that'd be on.
4 and 4.
Yes.
What do I know about 4?
They're all
That is
equal to
equal
Same as 2, so
two.
take that out.
Substitution.
And I'm gonna just put it in the order that they've got. I take the 3 and replace it where the 5 was. So now I have 1 plus 2 plus 3 is 180
Because substitution.
because of substitution.
Collins, you get that?
All right. Which one do we want to start with?
3,
5, and 4.
All right. Angle 1 equals angle 4. Y'all. Angle 3 equals angle 5. Alternate interior.
1 plus 2 plus 3 is equal to 180.
And that's a straight angle. I knew that. I knew that step.
I got that one too. I couldn't get the straight angle numbers.
You do 4 and 5 and substitute.